7.3 Volume, the shell method. Homework question number 3. Use the shell method to set up and evaluate the integral in order to find the volume of the solid generated by y equals x squared, x equals 0, that is just a y-axis, and y equals 4. So this is the region that we're going to revolve, and it's about the x-axis. And the question said set up and evaluate. That means we need to set up the integral and just calculate the integral. Now, because the axis of revolution is the x-axis, is horizontal. According to the notes, the summary of the shell method, for horizontal axis of revolution, we will use dy. So we call for the formula 2 pi times the integral from a to b, p of y, h of y, dy. Then we plug in the numbers. So it equals 2 pi times the integral from a to b. And because we are doing dy, we need to look at the y range that the region covers. So it's from here to here. So y is from 0 to 4. For the shell method, the rectangle is parallel to the axis of revolution. So this is the rectangle that we are considering. And P of y is talking about the distance from the axis of revolution to the rectangle. So in this case, it's from here to here. And because we are doing dy, we just need to find the coordinate of that point. And that point is just y. So P of y equals y. H of y is the height or the length of that blue line. And it's from x equals 0 to the curve y equals x squared. Now, because we are doing dy, we need to express it as x equal square root of y. So h of y is just square root of y, then dy. Now this is the integral that we set up. Then we need to evaluate this definite integral. So we have 2 pi times integral from 0 to 4, and we simplify the expression y times square root of y, which is y to the first power times y to the 1/2 power. And the power, you need to add them. So it's 1 plus 1/2 y to the 3/2 power dy. Now we apply the power rule. So we get 2 pi times the antiderivative y to the power is 3/2 plus 1, because power increased by 1, so we get 5/2. Then we would divide by the new power. It's the same as multiplying the reciprocal. So it's times 2/5. That is the antiderivative. We need to evaluate it from 0 to 4. Now you will need to use a calculator to get the final answer as 128/5